Back in the early days of video game industry, the process of creating video games was different than it is today. We're going to talk about the history of game software, specifically game engines, and how they were developed over the years. So basically, a game engine is a software that is considered a platform that gives developers the tools necessary to bring their unique games into reality. But in the early decades of video games, in the 70s and 80s, the term game engine did not exist. In those years, developers had to write code for everything from scratch. It took ages to build anything because they had to write code for everything, which meant they were spending less time on the creative aspects of making a video game, like graphics, game design, and fun. In the early 1989, one sci-fi game engine named Ultima Underworld was developed, and the engine had the same name as the game itself. But after releasing the Space Rogue game, Origin System had undertaken the Ultima Underworld engine and developed the algorithm for texture mapping, which can be applied to floors, ceiling, walls, and so on. Voxel Engine 1992 was the basic engine for all Komachi games. Voxel had their own way to represent volumetric objects as three-dimensional bitmaps. For that, all engines apply vector graphic, which was a little bit slower in speed and less detailing than a 3D bitmap presentation. Blade Runner, Command & Conquer are a noteworthy games developed by Voxel Engine. Before the 1993 release of its upcoming game Doom, id Software issued a new release. It promised that Doom would push back the boundaries of what was thought possible on computers. The press release is a remarkable document. It summarized stunning innovations in technology, gameplay, distribution, and content creation. It also introduced a term, the Doom Engine. This term described the technology under the hood of its latest game software. The news release promised a new kind of open game, and sure enough, its game engine technology became the motor of a new computer game industry. Doom Engine was not a 3D engine at all, but had the capacity to represent objects, characters, and whole level maps by 2D sprite representations. Rendering was very fast, and it needed a 368-based PC with standard VGA support to run. Though it was a 2D engine, the illusion created by developers made it look like it is a 3D video game. In late 1993, another game called Duke Nukem 3D was released into the market, which was developed with the help of Build Engine. Like Doom Engine, it also created 3D effects in a 2D interface. It simply varied the sectors with different heights to achieve the illusions. By applying special tags to various spots within a particular sector, developers could make it that whenever a player moves over that particular spot, it switches over a different sector, giving the illusion of changing the levels of environment at runtime. Xengine 1995. It was the first ever 3D engine which was developed in DOS base. It would later make use of high-resolution graphics and can be compatible with 3DFX video cards. Quake Engines 1996. It was the first truly 3D game engine by id Software. It had a unique processing capacity to render maps by purging certain areas from processing that the player wouldn't be able to see. It actually took advantages of Z-buffering, which is simply a method for determining which parts of the maps are visible to the player and only rendering those sections. Renderware 1996 was the most popular engine for multi-platform games. It supports PlayStation, Wii, GameCube, and Xbox. Quake 2 id Tech 2 Engine 1997 supports native OpenGL, colored, lighting effects, and C language support. The modability was increased because of its DDL support. Gold SRC 1998 pushed PC games to a new era. It supports both OpenGL and Direct3D. Some successful game examples which are based on OpenGL are Half-Life, Day of Defeat, and Counter-Strike. Unreal Engine 1998. It gave birth to Unreal Tournament game. It integrates its own scripting language called Unreal Script and map editor named Unreal ED. A modified version of Quake 2 engine was Quake 3, designed in 1999, which supports 32-bit color, shaders, and advanced networking. In 2001, Torque Engine was developed to modify the FPS Tribes 2 game. It had on-the-fly rendering option with less polygon counts and also had a world map editor integrated with it. Serious Engine 2001 was designed to allow large spaces and large numbers of on-screen characters at any given time and give birth to the popular Serious Sam series, Later in Doom 3 2004, most light surfaces were also done in real time, allowing more realistic shadows but at the expense of being able to render soft shadows as well. To get around this, projected lights could be used to create the illusion of soft shadows. CryEngine 2004 used pixel shaders for realistic water in Far Cry. Developed by Crytek company, it produced the game named Crysis, a shader-heavy DirectX game. Half-Life 2 created Source Engine 2005 included advanced shader technology, dynamic lighting and shadows, physics, several effects such as a realistic looking reflective water surfaces and a real-time motion blur, and much more. Rage Engine 2006 combined a rendering framework, physics engine, audio engine, network libraries, animation engine, and scripting languages in one package. Grand Theft Auto 5 was the finest product of that particular engine. In 2007, Unreal Engine and 2008, Frostbite game engine took the advancement of game engines to the next level, and up to 92% of the environment can be destroyed with unbelievable blasting effects was created by using Frostbite engine. In this video, we mentioned the early history of video games and the game engines that were used in order to create video games at that time, up to close to what we see in modern games. If you have something to add, please leave it in the comment section below. Also, you can check some of our previous videos. Thank you very much, and I will see you in the next one.